Hi everyone. Today we are going to build an image similarity search app using Clip and FAISS. Before I explain you about the code base, let me tell you a little bit about myself. I am Akansha Saxena, a web developer who recently gained interest in AI and machine learning. I record videos on anything new in tech world I learn because you know what they say, the best way to learn something is by teaching it to others. So let's start. Have you ever wondered how Google Images can find visually similar images almost instantly? You upload one photo and in seconds it understands and matches it to the million of others. For example, I'll say blue flower blue flower, and if I go here, it is returning pictures of blue flowers. So how is it working? I have tried to build a tiny minimal version of that using only open source tools. So you don't need any license, all you need is a will to build something really cool. So what are we going to use to build this really cool app? Before I explain you about that, let me show you what we are going to build today. So I have built it on Python. I have used a virtual environment. So I'm going to activate the virtual environment. So I'll do bin. Let me maximize it so that you can see it, right? And I'll say source bin and activate. Okay, so I'm inside my virtual environment and let me show you what I have built. So let me run it. Run Streamlit and app, and let me close it. Okay, so this is what we have built. We can go upload really cool images. For example, I can maybe upload an image of my cat. Cute, no? Yeah. So the image is added to the index to our server. Now we'll go we'll search by a similar similar image. So what we are going to do, let's say I'm going to test it using this image. So this image is of a nature. Our app is returning similar images, top three images of nature, see, right? And let's say if I want to search it with the text, I'll say cat. See, it is returning cat. And if I upload a cat image, not that, the dog, cat, let's see what it will return. Cat, see, it is returning cat. I do not have other images. I'll talk about the limitations also, but see, it is the first image is of the cat. So this is what we are going to build, an image similarity tool. Excited, right? So let's start. So we have used two open source tools. First is Clip and second is FAISS by Meta. Now Clip, if I go to the official website of Clip, I just write it, not Clip, model by OpenAI. It will take me to the official page, the Git repository. Here I can understand a really complex definition of Clip. It is a neural network trained on a variety of image and text pairs. It can be instructed in natural language to predict the most relevant text snippet given an image without directly optimizing for the task. Similarly to the zero-shot capabilities of GPT-2 or 3. Okay. Now if I explain it in easy words, it is a model that converts image and text into embeddings. Now what are embeddings? Embeddings, you think of embeddings in like a numerical vector, a numerical array. Let me show you. Numerical vector like a vector with numbers 3, 4, 4, 2, 2, 4, 4, 4, 5, 3, 3. A vector like this, right? So this clip model converts images and text into embeddings and places them into the same vector space where they can be meaningfully compared. Understood? Now then we use FAISS, which is a fast AI Facebook, not Facebook. Let me go and search, get you the official definition. So it is a Facebook AI similarity search. It is again an open source library developed by Google AI Research for efficient similarity search and clustering of dense vectors. Now to explain you in simple words, it is a library designed for fast similarity search over large collection of embeddings. We are already storing images in the form of embeddings, right? So we will use FAISS by Meta to search for the similar images fast, right? It helps you find the nearest matches efficiently. We define how and what algorithm we should use to find the nearest matches, and both of these tools are really cool and small and are really lightweight for these small projects. So we are going to use it. I've already showed you the demo. So before we understand the code base, let me explain you what we are doing. Okay, a little high level of the code base or the architecture of the app. So what we are going to do, when we upload the image, we are going to use clip to convert the image and text into convert the uploaded images into vector embeddings, and then we are going to use index management to store it. Now there are two instances, search by keyword and search by uploading the image. If the user searches by uploading the image, uploaded image is converted into the vector embedding using the clip, again same model, and then we go to the FAISS index management to return us the top case similar embeddings, and then we return it to the user. Same with text. Whenever we get a text, whenever user is searching using the text, we converted it into a vector embedding using clip, and then we find the top case similar embeddings using FAISS index management. So this is what we are going to do. If you look closely, we have two components. We have three components actually, and FAISS index management, a clip model for converting the image and text into embeddings, or I say generating embeddings, and then an instance of uploading the images or providing the front end, right? So we have three components. Before I start explaining it to you, everything you can find on my Git repository, and this is the blog version of the app. Whatever I am saying is already explained. So the code is already pushed to the GitHub repository. You can see it, you can understand how to run it and everything, right? So yes. So what do we have? We have two folders here, a core and Streamlit UI. This is for our front end. We have for the front end, I am using Streamlit because it provides you an easy way for building a data science related or machine learning related application. So yeah, for the back end we have four files: clip UI, config.py, FAISS management.py, and storage.py. Let's first talk about the config.py. Yes, this one. So I've created this file first to store the configurations needed for this application. How many similar images we want to show to the user? We want top 3 images. So this is what I have defined in this file. Then I have defined where to store the images, the directory for that, where to store the index, the directory for that, and create those directory if they do not exist, right? So I'll show you. If I come here, this is the architecture. I should be able to see a directory here created. See, it is storing all the images that we have uploaded. This was the image that we uploaded to see how it works. See, it is stored in this directory, and we have defined the directory location in config.py. So all and everything related to the configuration, basic configuration, we are storing it in this file. Next we have clip_utils.py. We have created this file. We have created this file to integrate with the clip model. Right. So what are we doing here? We are using torch. We are importing clip. We are importing the image from the PI library and then the config file. We are checking if CUDA is available from torch. Then load that as our device for this application. Otherwise, load the CPU. Why we are doing it? Because CUDA is, if it is available, it is obviously faster. So our application will be able to run faster. Then we will load our model and preprocess a function that will resize, crop and normalize the images which is required by the clip model. Okay, and we are loading the clip model VIT-B/32. It is the model pre-trained by OpenAI. Here we mention on which device we want to load this clip model. Now we have two functions, get image embedding and then get text embedding. Get image embedding, we have this function to convert the uploaded image into the vector embedding and return it to the function calling this function. And same with the get text embedding. Now let's understand what are we doing. Let's assume we have passed the image path, the string path of the image where it is uploaded. Right. Now what are we doing here? First we are loading the image from its location. Okay, and we have created a PIL object. Then we use the preprocess variable that we had received from the clip model, which will help us resize, crop and normalize in the range of 0 to -1 as required by the clip model. Okay, then we will do what? We will add batch dimension to make it 4-dimensional. Why do we do it? Usually what happens, all of these models are trained to work with a large size, a large batch of images, right? Here we are just passing it to work with only one image. That is why it is usually in the 4-dimension. The first dimension of this vector is going to be the batch size, channels, height and width. So this is going to be so we are converting it to the 4-dimension, which is actually required by the model. And then we will do what? We move it from GPU to CPU. Once we do that, we mention that we do not want gradient descent to run, because we want our app to run faster. And without the gradient descent, evaluate the embedding. So it will return 512-dimensional vector embedding. So it is going to be in the form of tensor. So we have to first move it back to CPU and return it in the NumPy array form, and then when we return it. Same with text embedding. We are doing what? We are using clip.tokenize to tokenize the text, and then we load it to our device with the same torch.no gradient to say that we don't want gradient descent to run. We evaluate the embedding, and once we do that, we move it back to CPU and then convert it into NumPy array, and then we return it. Then we have FAISS manager file. Why are we using this file? We are using this file to integrate with the FAISS library. We are importing FAISS, of course. We are importing NumPy. We are importing OS. We are importing pickle. We are importing our config file, and we are importing shuttle. Why we are importing all of that, all of those libraries, we'll understand later. Before that, what are we doing? First of all, we are defining the dimension of our clip embeddings. If you remember the clip embedding, it is returning a 512 dimensional vector embedding. So here we are defining the embedding dimension as 512. Okay. Then here we load the index file and the image path file. So we have two files for our index management. First is a file to store the image path, and second to store the index of files, the index of embeddings. This image path is stored in the serialized format, so that is why we had to use pickle library. So we have defined the index file path and the image file path. Okay, so we are loading first our index file. We first check if the index file exists, load our index using that index file. So we mentioned FAISS.read index using that index file and then load it into our index variable. Otherwise, create an empty index using L2 distance. We are using Euclidean distance to evaluate or find the similar images. Again, I am going to repeat, we are going to use L2 distance. We are going to use Euclidean distance to find these similar embeddings. So if the index file does not exist, we are going to create an empty index. Once that is done, we do what? We load existing image paths or initialize a new list. So if the image path exists, this file, we load it, otherwise we initialize it as an empty array, empty list, right? See, this is why we have used pickle. We have four important functions here. First, save index. Second, add to index. Third, search similar. Fourth, reset index. We will first understand two functions, add to index and search similar. Whenever a person is uploading an image in K, what are we doing? We are adding it to our index management storage. So we do that by calling this index add to index function. Okay, so what do we do that? How do we do that? We get the embedding of the image to add and the image path. We add the embedding using this function called index.add, and then we append the path of this newly added image to our image paths list, and then we save this new state using this save function. Okay, so we call this save function, which write the index to this index file so that our index file is up to dated, and then we dump this image path to our image paths file in a serialized format. Have you ever wondered, why am I complicating things? Why am I even using this index files and this path images? I can simply do it without it, right? I get it, we can. But to make our application persistent, so for example, if I run my application, if I shut down my system and come back tomorrow and run my application, I should be able to see my already uploaded images. That is why we need a persistent way to store them. That is where we are storing everything in our index files and path files, and we are loading it. So this is how we have made our system persistent. This is how we have made our FAISS index management persistent. Okay, so we have understood what is happening in the add to index. Then the other function is what happens when someone searches for the similar image. When someone searches for the similar image, we will get the embedding of the image using the clip, and we will mention how many, the default case, how many top similar images we want. So here we first check if the index is empty. We do not need to search, we just return an empty list. If the index is not empty, we use the index.search function to find the similar embeddings. How many? Top k. This will return us the index and the indices of those, and then we iterate through our similar images, we iterate through those indices, and we append the image path to our similar images array, and then we return it. Did you see that I have an additional if check here? So what happens? There is a limitation with FAISS. Even if FAISS does not have enough images, it will return something, because we have mentioned it to return top key images. If let's say if we have only one image in our index, right, we have only uploaded one image, now we are searching against that one image, we should at max get only one image, right? But what FAISS does, it returns top key images. That is why we need to check if the indices of the images is -1. Just don't return it. I don't want anything bogus here. Now we'll talk about the last function, which is reset function. So I'm going to go and show you. We have another tab called reset function. When I click on it, it says index reset successfully. So what it does, if you remember, we had a lot of images inside this. We had 2 files inside this. So what this function is doing, it is deleting all those files. It is deleting the index files, it is deleting the path file, it is deleting the image directory, this directory, okay, and then it creates it, and then I define all the image path and index again back to the empty index and empty list. So this is the crux of the application. Then I'm going to talk about the last file. We have all understood how to convert the images using clip_utils. We have also understood how to find the similar images, how to add it to the index, but we did not understand how it is getting saved in our system. So to save the uploaded image to our system, we are using this save uploaded image method. Okay, so we get an uploaded file from the browser, and then we find the extension of that image. Then we create a unique file name, then we create a image path, we pass the image directory and create a unique image path, and then we upload to that path, and the path comes out to be this inside this directory, because we have mentioned the directory name here. Why did we use the unique name? Because I do not want a conflict between the images. So that is why to create a unique name, I have used universally unique identifier, okay, to create a unique images. And then we upload the images. We need to have a function to remove the uploaded images also. So this function will remove the uploaded image. It will file the image using the image path, remove it, and then say okay, the file. If the image does not exist at that image path, it will simply say that the file does not exist. So this is the backbone of the application. Now let's understand the front end, what we have done here. Okay, so we are using Streamlit as I've already mentioned for building the front end. So we are importing that. We are importing sys, os, and logging. Why do I have to import or write this line? Because since I was running this application in virtual environment, my application was not able to figure out the packages inside this core directory. So that is why I had to write this thing, and this line to not show me the warnings. Now we'll import the other files that we have created. The clip utils file, we'll import the get image embedding method, get text embedding method. We'll import the add to index search similar reset index method. We'll import the save uploaded method and remove uploaded image method. Then we will import our config files, and then we will import the image. Do we even need this? I don't think we need it, so I'll have to remove it, right? Now we'll create a couple of functions. I've created a helper function called handle uploaded image. I'll talk about it later. Let's first understand the Streamlit UI. First, we create the page configuration, as in how is the layout going to be, and the title of the image. We set the image title here, which is coming like this. For example, if I say app, see app. So I can remove it. So this is working, right? Then we define 3 tabs: tab 1, tab 2, tab 3. Tab 1 is to add images to the index, tab 2 is to search similar images, and tab 3 is to reset index. In the tab 1, with tab 1, what are we doing? We are mentioning that we want a file uploader which says upload an image. And what type of images are we allowing? JPG, JPEG and PNG. And the key for this uploader is going to be add image. Why do we have to mention the key? Because we have two uploaders here. So in order for these two uploaders to not get confused, to not have a conflict, we have to define a key here. Here we say whenever this add button is clicked, take the uploaded file and then get the image path of that uploaded file. So if we go to the helper function, what it does, it takes the uploaded file, saves it to our system and display onto the front end and return the image path. So what it does, it first checks that the uploaded image is not none. If it is not none, save it to our system using the save uploaded image method, and then show it on the front end with the width 250 and then return the image path. So whenever we upload, let's say I'll upload a dog picture, see it is returning on the front page, right? Sorry, on the front. So this is how it is coming. Once we get the image path, we call the function called get image embedding, pass that image path and we'll get the embedding. And then we use the function add to index to add that embedding and image path to our image paths. Here it has added to our image directory, and the image path file and the index file are created. Once that is done, this is the whole function of this tab, this add image to index tab. Then we have the second tab, search similar images. With search similar images, we have 3 radio options. What do we want to actually do? Do we want to search by image, search by text, or we want to do nothing? So let's say we click on none. We say okay, please upload an image or enter a text to search. Okay, so if the action item of this radio button is search by image, we again have uploader. So this uploader with a different key, we first check if the search button is clicked. If it is clicked, we call to the same handle uploaded image helper function and we get the image path. We call the same get image embedding function to return us the embedding, and then we remove the uploaded image. If you remember, this function saves it to our system, right? Saves it to our system. And if the person is searching with an image, we do not want to save that to our system, right? So we remove that uploaded image. And the same thing we do if someone is searching by text. We first, when we click on this search by text, it shows us a text button. It shows us a text query button. And then if there is any input in the text query button and the search is clicked, what are we going to do? We are going to generate an embedding from the text. And once we have the embedding, what are we going to do? Once we have the embedding, we check it using the if condition. We search for the similar images using that embedding, and we mention how many images we want, config.topk. And if we want to change it, we'll simply go and change it in our config.py file. So here we mention how many top images we are returning, top, which is 3. And if we have some images, just show it to them with width 200, otherwise show that no similar images found. Simple and sweet. Okay, and the last button, which is reset index. Here we simply check if the button reset entire index. This is clicked. If it is clicked, call to reset index button and show a warning that index reset successfully. So this is how I have built really cool, simple image. Let me show you image similarity. Before I wrap up this video, there are many limitations to this app. The limitations are that as I've already mentioned that this Facebook AI similarity search always returns top case similar images even if the image is not there in the index. Then in that case we had added a check. Then the other limitation was that the clip embeddings are semantic. So two photos of the same cat in different poses don't necessarily come close in the embedding space. So that is one limitation that I've encountered. Last is when I was working with these two file uploaders, I had a little bit of challenge on understanding how to make it not have a conflict between. So that is why I figured that I had to add a different key to both of them. So that was one more thing that I've learned. So yeah, it was a really cool simple app. You can also build it. You can find the code from my Git repository, and yeah, let me know how you find it. If you find any challenge in building it, just comment it out. I'll go and check it and make sure to reply you. Yep, thank you very much.